Okay, so good morning. Okay, fine. So, quick revision of what has happened in previous two classes. Two classes, no? Two classes. I think you are absent for one. Present. Okay. So, quick revision of what has happened in previous two classes, right? So, where did we start? We basically started with the basic definition of electricity, right? So, we said electricity is flow of charges. Electricity is flow of charges, and I said charges are of basically two types, correct? Positive charges and negative charges, right? Positive charges are carried by protons and negative charges are carried by electrons, right? So when we are dealing with electricity in our real life, the purpose why we are studying with the purpose that we want to study about the flow of current, flow of electricity through these wires and all other circuits that we see in our daily life. So that means all those consist of metals. So when it comes to metals, I said we are interested in studying about the negative charges because metals have free electrons, and it is because of those free electrons we see the movement of electrons, which we call it as electric current. Electric current, right? And we also defined electric current as, how do you define it? The basic definition of electric current is the amount of charges flowing through a conductor per unit time, correct? This is how we defined it, right? Okay, so when we said the current is amount of charges flowing per unit time, then we also said that charges are measured in the unit called coulombs, and time is obviously measured in seconds, which means the current has SI unit of what? Coulombs per second, or in honor of a scientist called Ampere, 1 coulombs per second is also called 1 ampere, right? Okay. Then, what did we study after this? Okay. What was the charge consisted by 1 electron? Okay, we'll come to that. So, what was the charge consisted by 1 electron? Correct. So, to calculate that, what we said that 1 coulomb of charge. Why you are speaking about charge? Because current is flow of charges, correct? So we said 1 coulomb of charge consists of how many electrons? 6.25 into 10 to the power 18 electrons approximately, correct? Okay. So with the help of this, what we found out, we calculated if 1 coulomb of charge consists of these many electrons, then what is the amount of charge consisted by 1 electron? That means 1 electron carries how much charge, right? We calculated that, right? We got it how much? Approximately 1.6 into 10 to the power minus 19 coulombs. Minus 19, I think. Okay. It is correct only. When you write 0.16, it is difference. Right? 1.6 into 10 to the power minus 19 coulombs is the charge consisted by 1 electron. Right? Okay. So after this, I think we studied about some of the basic components of electrical circuit. So what is an electric circuit? It is a complete closed path of an electric current. Now why are we saying closed path? For the current to flow in an electric circuit, it should always be a closed path. If it is an open path, then there is no flow of current, right? So therefore, to connect and disconnect that path, we have a component called switch or plug key, right? So if it is in open position, then there is a disconnection between the conductors, therefore the current flow stops. And if it is closed, then there is completely closed path of the circuit, and the current starts flowing, right? Similarly, we also saw some of the electrical components like How is a cell represented in circuit? How is a battery represented in circuit? Correct? And how is a resistor represented in a circuit? What exactly is a resistor? We have not seen in detail about it. Of course, we will see in the coming classes. Basic idea I have given you. What is a resistor? Correct? Then how is voltmeter represented? How is ammeter represented? Huh? Then what else? How is a rheostat or variable resistance represented? Correct? So we have symbolic representations for all the electrical components that we use in our daily life. So we have seen those. Whenever two wires come across, how they are connected when they are joined, and how they are represented when they are moving over each other without joining. Right? All these things we have seen. Right? Okay. And we also solved some problems. Of course, I had given I think 3 or 4 homeworks. Correct? You have solved. Okay. We'll see at the end of the class how much you have solved. Yes. What is a charge? Huh? Definition. Uh, it is when I see every body has some charges. Like it is part of the material. You studied in chemistry, right? Basic structure of a material consists of molecules and atoms. What does atom consist of? What are those? Those itself are called charges. Materials are made up of charges, nucleus, electrons, protons, all this. Correct? So they are part of materials basically. If it is a tree, leaves are part of the tree, correct? Fruits are part of the tree, branches are part of the tree. Similarly, charges are also part of the materials, correct? So, of course, some of them get free in some situations because of which there is a flow of electricity. So, starting we have discussed there are two types of charges, all those, right? So, this is what has happened so far in the previous two classes. An overview of previous two classes for those of you who not attended and those of you who joined fresh, right? Okay. Now coming to today's class, today we are going to study what is called an electric potential and potential difference, right? Okay, out of these four words I have written here, are you familiar with any of the words? Potential. Okay, where does it come from? Okay. Ninth standard, correct? Work, energy, power. So in that topic, I think we have learned about when we were studying about energy, right? There were two types of energies: kinetic energy and potential energy. So there you have come across the word potential, right? So how did you define potential energy? Anyone? Anyone? Yes. The energy possessed by an object due to its height. Correct? So let's try if we can link up with that word and try to understand what is the meaning of electric potential and potential difference. Right? Okay. For this, let us consider some things to understand. Right? Some analogy. What is that analogy? Okay, now let us say there is one pipe, right? And inside this pipe, there are some marbles, not laddus. Inside this pipe, there are marbles, correct? Okay. Now, when I keep this pipe exactly horizontal, it is an exactly horizontal position, not inclined this side, not inclined this side. Tell me whether will the marbles move? Whether will the marbles flow, whether this direction or this direction, will they move? No, correct? So, from your ninth standard physics understanding, if we make one of the side of the pipe inclined, now what happens? Marbles start moving on the that side towards which side it is inclined. What I have done basically, I have given some height to one of the side, correct? I have given certain potential. If we link up with 9th standard physics, potential is something that speaks about height, correct? So I have given certain height to this, so marbles start moving this side. So it is because of the height, because of that potential, marbles are moving, right? Okay. Now, same analogy we will take, except that the meaning of potential is slightly changes when it comes to context of electricity. Slightly changes, not much of it. What is that? In the case of a pipe and marble started moving only when they were given certain height from one side. They were given certain potential. Now, what is electricity? Electricity is flow of charges, correct? So assume this pipe as a conductor or a wire, and assume these marbles are, let us say, electrons. So we said flow of charges, which means they have to be set in motion, correct? They have to move. But can they move? No. That is as per 9th standard, correct? As per 9th standard, what is the understanding? You have to make it certain height, give it certain height to make them move forward. Let me complete first, right? So that means, but we cannot make the wires inclined, no, in real life. And inclination kodkothodra, from right from the HESCOM station, it should be completely inclined, correct? HESCOM power station should be located on certain hill. From there, wires should be all inclined towards your houses. Yes or no? Correct? So it's not how it works. So in the case of electricity, it is something called the battery or cell is responsible for the movement of electrons. How it is responsible? Let us say this pipe is again connected to this battery. So battery is consisting of chemicals, you know that, right? There are a lot of chemicals in the battery. So there is a chemical reactions within the battery which are happening, and due to those chemical actions, the battery is continuously producing electrons. If it is continuously producing electrons, they have to be set in motion, because otherwise all the electrons would stay inside the battery itself. The very purpose of cell or battery is to obtain energy from it, to get energy from it, electrical energy. Correct? So if you connect this pipe to a battery, this battery or cell is continuously supplying the electrons. So if it is supplying, that means electrons, they have to move, correct? They have to move. So they have to continuously move in that path. So basically what I mean to say is, it is the battery or the cell which generates that potential. It generates that potential or height in case of 9th standard. It is the giving a virtual height or a virtual energy, a virtual potential, which is making these electrons to move in this pipe or conductor. So because of which these electrons move in this conductors. These electrons move in this conductors. So it is the battery or cell which is providing that energy, right? So we will, of course, those energies, of course, used by the appliances in our life, the bulb, fan, or whatever electrical appliances, right? Okay. So that is about battery and cell. Okay. Now I said the cell is the one which provides that potential for the electrons to move, right? Now let us come to the definition of electric potential and potential difference. So in that chapter of 9th standard work, power energy, we also studied about work, correct? What is SI unit for work? Work is measured in joules. Of course, energy is also measured in joules, correct? Okay. I said these electrons moving. That means some amount of work has to be done in moving these electrons from one place to another place. They will not travel by themselves, yes or no? Will they travel by themselves? It is because of the chemical action of the battery, these electrons are moving from one place to another place. Correct? That means some amount of work is done on these electrons in moving from one place to another place. Correct? So electric potential is basically defined as the amount of work done in moving a charge. In moving a charge. Charge means it can be electrons in this case. From infinity to a point. Infinity means some very far distance, right? To a point and anywhere in the conductor, anywhere in the wire. That is what is called electric potential. Now, when it comes to potential difference, when it comes to potential difference, slight change in the definition. What is that? Same thing, the amount of work done in moving a charge. In this case, it was from infinity, a point which is very far away from this point to this point. From there to here, if you want to bring 1 unit of charge, 1 coulomb of charge, then that is called electric potential. Now, in real life, all the wires are at nearby distance, correct? So, the amount of burden in moving a charge from one point to other in a conductor. In a conductor. Conductor means a wire. So let's say I want to transport 1 coulomb of charge from this end to that end. How much work is done in moving a coulomb of charge from this point to that end of the conductor? That is what we call potential difference. Of course, we have to represent it in the form of mathematical equation. Then only we will be able to calculate certain things, right? So potential difference in real life is represented by the letter capital V. Capital V. So V is equal to work done in moving a charge from one point to another. That means work done per unit charge. If you remember, Q we represented for charge in previous class. Yes or no? Right? And W is what? Work done. Correct? Now tell me what is the SI unit for potential difference then? Joules per coulomb. Right? So work is in joules, charge is in coulombs. So therefore potential difference is joules per coulombs, or it is also called by another name, volt. It is also called by another name, that is volt. So we can say that 1 volt is equal to 1 joules per coulomb. 1 volt is equal to 1 joules per coulomb. Meaning what? If you transport 1 coulomb of charge between any 2 points, then we say that the potential difference between those 2 points is how much? 1 volt. The potential difference between those 2 points is how much? 1 volt, right? Okay. So you can write down this. So we are trying to solve one problem from this potential difference, right? Okay. So just read the question for me, somebody. Karthik.
Calculate the work done in moving a charge of 3 coulomb between the 2 points in a conductor having a potential difference of 12 volts.
Okay. Calculate the work done in moving a charge of how much? 3 coulombs, right? Between 2 points in a conductor. Between 2 points in a conductor having potential difference of how much? 12 volts, right? So what is given to us? So whenever you are solving problems, always you have the habit of just writing numbers randomly and just 12 by 3 then 12 by 3 if you'll write equal to 4 you'll write it and wind off. What is that 12? What is that 3? What is given? No systematic way of solving till now. In spite of trying to implement that habit from 1 year. Even in SA2 also same. See here. So in spite of having told to many times, still you do not have that habit. Please change that habit. In some corner you will write 12 by 3 is equal to 4 over. It does not have unit, it does not have anything. That representation is very bad. I have been telling you this since 1 year. Still same thing. Same pattern was also observed in your SA2 examination also. Right? Change that. Whenever a problem is given on any topic, anything, first you write what is given to you. Then what is the relevant formula for that? Then you calculate. That's the way to do it. Right? Okay. So in this problem, first you write what is given to you. So charge is given as 3 coulombs. 3C stands for 3 coulombs. Correct? Okay. And then potential difference is, as I said, represented by the letter V and is given as how much? 12 volts. Right? Okay. What do you need to calculate? You need to calculate the work done. So work done is not given to us. That is what you need to calculate. What is the relevant formula? V is equal to W by Q. Right? So we know that V, that is potential difference, is equal to work done divided by the charge. Divided by the charge. So V is given to us. Yes. Q charge is also given to us. Correct? Okay. We need to calculate W. So that means W is equal to V into Q. Correct? So V is 12 volts into Q is 3 coulombs is equal to how much? What is the unit? This also will forget many times. 36 joules. That is the answer. Correct? Okay. Work is given as how much? 7 joules. Okay. Is done to move a certain charge. That means we don't know the value of charge. Correct? Between 2 points in a conductor having potential difference how much? 1.75 volts. Okay, calculate the amount of charge. First you have to calculate the charge. If you are able to calculate charge, the problem is half solved. That's it. Then after that, you know how much electrons are present in 1 coulomb of charge, then you can multiply and find it out. Right? This side, Prajwal. So first job is to find out the amount of charge present. So what is the relevant formula, Prajwal? V is equal to W by Q. Get used to these formulas now. You have it's time you have to start preparing this. What is the first formula? I is equal to Q by T. Current is amount of charges flowing per unit time. I is equal to Q by T. The next formula that you are coming across is V is equal to W by Q. Some more formulas you will come across in this chapter. Okay, those are things you have to remember, right? Okay. So V is equal to W by Q. So you know that unknown quantity is only Q. W is given, V is given. I don't know why some of you have multiplied directly 7 into 1.75 without even seeing. Vaishnavi. Huh? So just first, that's why I write, first you write the relevant formula, bring it to a point where unknown things are on the one side, known things are on the one side, then you will be able to identify properly. So what is the unknown thing? Q. So Q I want to find out, so I will bring it on the LHS. Left hand side is equal to W, it stays where it is, and the potential difference comes to the denominator. Directly without even thinking, don't multiply. Right? Fine. So Q is equal to W is how much? 7 joules divided by V is 1.75. 7 divided by 1.75 comes out to be how much? See, sometimes do not always you need to go and take a rough page and do calculations. Think from the mind. What is 2 times of 1.75? 3.5. 1.75 multiplied by 2 is 3.5. If you divide 3.5 by 2, you will get 1.75. 3.5 is half of 7. Right? ಯಾವಾಗಲೂ ಹೋಗಿ division ಮಾಡೋದು multiply ಮಾಡೋದು ಅವಶ್ಯಕತೆ ಇಲ್ಲ. Right? So 1.75 is 4 times multiplied by 4 times gives you 7, or 7 divided by 1.75 is 4 coulombs by calculating charge. So that is the charge. What else you want to calculate? You want to calculate total number of electrons. So total number of electrons present in the charge is equal to 4 coulombs multiplied by 6.25 into 10 to the power 18. So 4 into 6.25 is 25 into 10 to the power 18 electrons. Right? Understood? Okay. Those who are not written, take it down.